Bueno, buenas tardes. Mi nombre es Clementina Equigua. Llevo la Oficina de Comunicación de la Ciencia como Aleida, pero en el Instituto de Ecología de aquí de la UNAM. Y en esta semana nos vino a visitar Sacha Vignieri. Ella es doctora en biología, por eso apareció por esa región de la UNAM. Y ella tiene la formación de bióloga, es especialista en mamíferos. Hizo un doctorado en Estados Unidos, trabajó en la Universidad de Berkeley, estuvo en Harvard, en Washington University, en Sussex. Y en algún momento de su vida tuvo la oportunidad de incorporarse al grupo de trabajo de editores de la revista Science. Y ahora que está aquí de visita, bueno, quisimos aprovechar su experiencia como editora para que nos compartiera un poquito de qué es lo que significa publicar en una revista de alto impacto. Hemos estado en varias instituciones, estuvimos ya en la Facultad de Ciencias y todo, entonces ahorita ella nos va a presentar una versión resumida, digamos, un poco enfocada a un centro de investigación como este. Y bueno, muchísimas gracias y muchas gracias por recibirnos aquí.
Muchas gracias, Clementina. Muchas gracias for having me. I'm sorry I cannot give the talk in Spanish. I wish that I could. I appreciate your speaking in English with me for a little bit. I also want to say that I'm a biologist and an ecologist, and so I'm hoping that the general concepts I'm talking about will apply to physics, and I'm happy to discuss how that might be once the talk is over and we have questions. But also there's some specifics to physics that may not appear in my talk, but I think it will still be valuable because much of the general way that we operate is the same across all the sciences. So we editors for science like to travel to universities and make visits, not just to meet people and see what people are doing, but also to provide some information and insight into the black box that is science. So I know certainly for myself, prior to becoming an editor when I was a researcher, and for most everyone else, science and nature, which often are put in the same box, are very much a black box. So you send off your paper, and then usually within a day or a week, you get it rejected, most of the time with no information as to why. And that's just the way it is. And so I would like to come and open up that black box a little bit and share with you some of what happens inside of it and why so many papers are rejected, what the process is like, and how you can best assess when perhaps it might be time for you to submit to the black box, which hopefully then will be a little bit more open. Before I get to the details, I like to give a little bit of history about science. So science was started in 1880 from a seed grant given by Thomas Edison, so it's a very old journal. This was the first cover for the journal Science when it first came out, and what you may be able to see is that the vast majority of things that appear on this cover are advertisements. So some things have not changed very much, but some things have. This is the first instructions to authors, and what you may or may not be able to read here is that the most important thing that you could do to ensure your paper would be published in Science in the very first issues was to write legibly. It was really important to read your handwriting, and as long as they could do that, you were in. So that has changed a little bit. So the current instructions to authors are this, and this, this, and this. It's become much more complex, the process of submitting and preparing, as well as much more competitive, as I don't have to tell you all. And the way we access content is changing. So it used to be when I was a graduate student, which wasn't that long ago, although increasingly long, was to go and sit in the library, pick up the issue from the stacks, and read through it. And now most people access papers in most journals online, and increasingly on their own personal tablets or their phones. Who knows what's next? Plug it into your brain. It's an ever-evolving process.
Twitter and Facebook.
See, Twitter and Facebook, yes. It's not moving this way. There we go. Okay, and of course how we publish. is changing very rapidly. So now open access has become very important. Just last week, the EU announced that all of the research that they fund must be open access by 2020. So that is a train that's moving forward, which it has some complexities that have to be ironed out, but it's going ahead. Another thing that you all will be very familiar with, that I was not very familiar with before I started this job, is the archive, which has for long been around in the physical sciences, but is very much brand new in biological sciences. And I'm very curious to see how it operates for biologists and whether it becomes sort of the standard practice there as well. So things are changing very rapidly. The internet obviously makes things available very quickly, and what publication means within that context is changing. Another thing that I don't have to tell you probably, but is that there is a lot of science being done at all the time. So this graph shows on the y-axis the average number of cited papers, and on the x-axis the last 100 years. That little pulse is right after the Second World War. What you can see is that it's been an explosion of science in the last 60 years. And all of that is happening while you all are trying to do research. And within this context of competition and publication, nature and science sit in a unique position because the community, for whatever reason, and I actually don't even know why, people have asked me this during this visit, why did this come to pass? But nature and science have become sort of the journals for many of the sciences to publish in order to get a job, get a grant, move ahead in your career. This is an actual cover that Science produced for an April Fool's Day cover the year that I started. And the main point of it is to talk about how science and nature are very much considered the same. In fact, we often get cover letters that say, "Dear editors, please accept my submission to Nature." There's really no differentiation often. But the two are different. So Science is published by the American Association for the Advancement of Science, which is a nonprofit. And the vast majority of the profits from Science, the journal, go into AAAS to fund things like science diplomacy and education. Nature is published by Macmillan, which is a large publishing house, which primarily means they have more money. So they have more opportunity to do things like publish many little journals like Nature Kitchen Sink, and to do a lot of experiments in how they publish things, start new sections that they can then determine whether they work or not. So they have a little more flexibility, and I think we have some nice things that we can do for science, the community. So Science has changed a little bit in terms of what we're doing. So Science Advances is a new open access journal that hopes to publish the top 20% of papers they receive and is publishing more broadly. So for example, they're publishing a lot more engineering, things like that don't appear in Science as much.
That 20% in Science Advances, this refers to what? To the
so what they determine to be sort of the top 20% of papers they receive. So we at Science try to think of publishing the top 5%. However, they're determined at that point, they're shooting for the top 20%. We also publish things like Science Careers, which I think is really helpful for students and postdocs, and doing a lot of more interesting things like producing the XX files, which try to feature women in science. I put this up there because it's kind of a fun thing that they've done recently where they took data and put it into a cover. This is solar wind, and they took the data from a particular paper and put it on the cover. So there's some exploration of things that they're doing now. And so Science will never become Nature in terms of publishing so many types of journals, but we have a few now. These two, Signaling and Translational Medicine, have been around for a while. They're biomedical. Science Advances is the new journal I mentioned, and then soon they will be publishing a Science Robotics and Science Immunology. Okay, so given the background of science and the background of how much science with a small s is being published, this graph shows the relative proportion of papers we can publish to papers we receive. So on the y-axis here is the number of papers that are submitted, on the x-axis is time. the red bars show the number submitted, and the blue bars show the numbers we can accept. And this is over the past 20 so years. What you can see is for 20 or so years, we've published 800 papers. But in that time, the number submitted has increased to where it's about 12 to 13,000 papers a year. So we receive 12 to 13,000, we can publish 800. But within that number of 800, we are publishing fairly internationally. Now, you probably can't see the outlines of the countries here, but using your map knowledge, probably what you can see is that most of the papers come from the US, the UK, or Europe. However, I think we're doing a pretty good job of publishing internationally. You can see that dots are appearing across the world. I'm always particularly impressed that we're getting so many papers from Africa and South America. We're doing well, and we're hoping to just keep increasing the proportion of papers we're publishing internationally. So, as I mentioned, Science's mission is to publish across all the sciences. And so this gives you an idea by percentage what we're publishing. Now, as you probably will notice, most of what we publish falls under the life science category, but we are publishing a fair amount of physics, 10%, and some chemistry. So the physical sciences at Science have definitely increased in proportion, and certainly over the last 20 or so years, much prior to my time, there was a conscious decision made to publish more physics and chemistry, and they are continuing to publish a good proportion.
Astronomy is considered inside physics.
Space sciences, they called it.
In space.
Yeah, so I didn't make this. This was made by, this particular slide was made by our art department. I don't know why they chose to call it space science. I don't know what else there is besides astronomy, but yeah. So our challenge at Science is to take all those 13,000 and narrow it down to 800. And I realize this analogy is not so great because if it were accurate, then most of the water would be spilling outside the bottle and only a little tiny trickle would be coming inside. But the point is to discuss how we have this challenge of taking all these papers and deciding which few we can keep.
Excuse me?
See.
According to that slide, it seems that the editors are the ones in charge of rejecting most part of the papers. Is that true? Or,
No, so I'm going to talk about the process. Yeah, okay. So the editors do not make unilateral decisions. We are responsible for handling a paper through the process, and I'll talk more about how that works. Okay, so since we are the ones who do have to handle this process, drive the boat, so to speak, many people wonder, and I did too when I was sending papers to Science and having them rejected, who are those editors anyway? Why do they get to make the decisions? And so I do just like to show a slide to show that we are actually people. There's about 22 of us. And to say that also in the last 20 years, Science has made it so that editors only are researchers originally. So all editors have PhDs. We all have multiple postdocs and have published many, many papers. And we were in some way either plucked or tripped into the job. And so that we like to believe in terms of our training and the fact that we've also been researchers, many of us for 10 years or more, that we are colleagues. So getting back to how we do this, how do we narrow? So when your paper comes in, along with the 12,999 others, it is assigned to an editor based on their area of expertise, what they were trained in. So my area is organismal biology. What that means is I cover all the things that have to do with an animal, sometimes a plant, that aren't model systems. So I do all the vertebrate paleontology, so the dinosaurs, all the way to fisheries, ecology, evolution, those kinds of things. So your paper comes in, it's assigned to an editor based on area of expertise. The first thing the editor will do is read your paper. And then typically they will write a little bit of opinion or thoughts about your paper. And then they will send it off to members of our board of reviewing editors. These are people who are active researchers that we, the editors, recruit to help us by giving us kind of informal reviews. And what we ask them to tell us is whether or not a particular paper would have a big impact in their field if we assume it's correct. So we're not asking them to really review the paper. in terms of the methodology, the design. We just want to know, does this conclusion excite you as a representative of your field? So then the editor will then take their opinion and the opinion of these board members, assess them, and come up with a recommendation. So then I might say, based on my opinion and the opinion of our board, I recommend that we send this paper to review. So that happens for 25% of our papers. The other 75% are rejected without review.
How many board of reviewing editors?
So we have over 100, and you can see them. Their names are all on the website. And I would say, that's across all the sciences. So I personally have between 5 and 7, depending on sort of the time in the cycle. And that's about average. So each editor, and some editors cover more narrow fields, so they might have fewer. So it really depends on how broad your field is, how many helpers you have. Okay, so if we send the paper to review, then clearly we have the review process, which is very similar to how it operates at every other journal. So we get over 2 reviewers. I like to get at least 3. Makes it easier for tiebreakers. And then we get their opinions. I, as the handling editor, assess their opinions. And then I make a recommendation, again, at this stage. So I might say, oh, there's clearly a lot of enthusiasm among the editors. I recommend we send this paper to revision. Or I might say, unfortunately, the reviewers don't think this is very good. I recommend we reject. And then I send that recommendation to the other overlapping editors, and then we make a decision, and then the paper ultimately will go through that process, usually just once, sometimes twice, and then less than 8% total are accepted, and the rest are rejected. So to get to your question, the editor sort of guides the process, but at no time does one single editor make the decision. And throughout, there's much discussion, and we also have these internal reviewers that are external people that help us. So obviously, the review process is important, and so people usually want to know how we go about choosing reviewers. We typically use one reviewer that's recommended by the authors, and then we use our knowledge of the field, other recommendations from our board members. Sometimes we do some searching, and our goal is to find reviewers that are ethical. That's our main criteria. We want them to be objective, constructive, fair, careful, confidential. We want them to tell us if they have a conflict of interest, as this woman very generously did. And then once we have these reviews, then we ask them to give us their opinion of the paper in terms of the quality. We'd like them to give us a synopsis so we know that they've read the paper and that they understand the paper and that they were the right reviewer in terms of field. We ask them for originality. And then the 2 things that might be a little bit different than they might be at another journal is we really want to know how they feel the paper will impact their field and what its broad significance is. Okay, so then we have the reviews in hand, and obviously the most obvious way the paper is rejected is because it's not rigorous, it's not sound, the conclusions aren't supported. But sometimes papers at Science are rejected for reasons other than this, and this is different than most specialized journals. So one big one is that remembering that Science is a general science journal, and that what we want is to put together an issue every week where the papers are accessible to people across the scientific fields. So we want people to say, oh, I can understand why that question might be interesting and relevant, even though it might not be in my field. So we're looking things of broad significance. And sometimes a particular study might be very well done, novel, and really excellent and important, but only pertains to a relatively specialist field or specialist topic within a field. Those papers are not best placed at Science, and in fact, I believe they do better and are better received when they're published in a specialized journal. The other one that happens quite often at Science, because it's Science, is that the most exciting parts are too speculative. So oftentimes researchers feel they really need to amp up the potential conclusions, and so they'll say things that actually aren't supported by the data or are, knock-on effects from their conclusions. and the reviewers tend to catch them and not like this. And then the other one is that it might fill out a field, so it might increase our understanding of a particular question or area, but it doesn't significantly advance it. And at Science, because we have to go from 13,000 papers to 800, what we're looking for are papers that are conceptual advance, that really move a field forward. And what we hope is that people within that field would agree that a particular paper is really moving the field forward more than even their work. So that's what we're shooting for. We don't always get it, and we definitely make mistakes, but that's the goal as we're thinking. Okay, so knowing the background of all this, the competition, the types of papers that do best at Science, the question is, when do you decide to open that black box and send your paper off? And so the first thing to think about is what types of papers researchers can actually submit. So the first thing is news, all that stuff in the flashy front section, we don't get to contribute to. But we do have quite a fair number of opportunities outside your classic research paper. And I think it's important to keep these in mind, especially when you're thinking about making commentary about how science is going or a particular field, what's going on in it. So the first one is that researchers often do write editorials. You can propose these. Letters are not peer-reviewed kind of opinion about something. Books, book reviews, researchers are often invited to write these. Policy forums are a really important thing, I think, to keep in mind, because they're the place where a researcher can connect a problem, societal problem or bureaucratic problem, to some scientific solution and propose that these two be linked through policy. So it's a way to link policy and science very clearly. Perspectives are shorter pieces that translate science. So oftentimes we ask researchers to write these for us about papers we've published, but they also come in on their own. So if researchers think of a paper that's just come out somewhere else or a set of papers that's really made an impact, they can write about it in a perspective. And technical comments, of course, if you see something wrong in a paper, you can point it out. And then to the basics, the basic research papers, reviews, same as reviews elsewhere, except they often end with a forward-looking glance at what's coming. Research articles are longer pieces, typically 4,000 words instead of 2,500 words, are supposed to have a bigger impact. And then reports, the sort of workhorse of publication in science. Those are 2,500 words, and I'm going to talk to you in a little bit about how to do that. And then the other thing to keep in mind is special issues, which are special collections on particular topics. We often solicit authors to help us write those. Okay, so getting back to whether you should submit to Science in any particular case.
Who decides the topics of the special issues?
So the editors all submit ideas based on what we've seen in our readings. We read 100 papers a week, so we read a lot. And then sometimes what our board members suggest, what people in the field suggest when we're out traveling. Mm-hmm. So we all submit those. And then the higher-ups decide which ones will be completed that year. So the higher-ups being the deputy editors, there are 3 of them for physics and chemistry, biology, sort of molecular biology, and organismal biology, along with the editor-in-chief. Okay, so the first thing you want to do when you're looking at your work is really be certain that it's rigorous and sound, because when something's published in Science, everybody wants to really test it out and see if it's right and poke holes in it. So just be guaranteed that you'll get that kind of feedback, and so just be really confident yourself that you feel it's right. So getting back to this idea that it should be general interest, that it should be accessible in some way across fields, that it has an impact. So we like to look for papers that move the field forward, that really impact the way people in a field think. And then, of course, there's the extremely rare case where a study will completely change the way people think. So some things that don't help when you're thinking about preparing: excessive speculation doesn't help, as I mentioned. The idea of the least publishable unit doesn't help. So I think people really would sometimes want to think about splitting their work up so they can get more publications, and that's certainly a good strategy. But when you're trying to send something to science, you really want to make sure you have the whole story there. And sometimes if you slice it up, you can split the story. So certainly if you try science and it doesn't make it, go back to trying to split the story to specialized journals. But when you're giving it a try at science, make sure you have the whole story together first. And then hype is when authors say things like, this is the first, this is the best, this is the most novel, these kind of words that don't have any specific meaning. Those don't help because everybody says them about their work. So make sure what you're talking about is the specifics of your contribution. This slide, I always like to make sure that I'm covering, even though most people don't believe me, but I'm going to say it anyway because I come from the inside. Where you come from does not matter. We really want international work. Who you are does not matter, and the prestige of your university does not matter. We are fundamentally looking for good research, and that's what we're trying very hard to find. So that's the truth. Okay, so then in looking, again, thinking about your research and when it's appropriate for science, it's important to keep in mind that the pace of science is very quick. So this is just an example of how quickly the forefront of science can change. So, 35, 40 years ago, the sequence of a gene was published in Science. I believe it got the cover. 30 years ago, the sequence of the human genome was published in Science. It definitely got the cover. Now you can't just get published in Science or Nature with a genome. You have to be doing something with the genome. So we have genomes as tools. We have these genome networks, transcriptomics, all kinds of things where we're producing entire genomes and doing things with them. And so what's next? So, in 5 years, these will be no longer at the forefront. So when you're thinking about submitting to a journal like Science, I like to use this football analogy because I think it really describes well sort of what the process and how science moves. So if you think of yourself as the red ball and science, big S and small s, as the blue ball, and that soccer ball is your science, your work. If you try to pass it just straight across, then by the time it gets to me, being the receiver for science, I've already run ahead, right? So you have to lead the ball, lead the pass. And you have to do that in science too. You have to think ahead. So you have to look at your work, read widely in your fields. Where are your fields now? And where will they be going? What questions remain to be answered? And those are the ones you want to think about submitting to a place like Science. Okay, and I know this is not in your field, but I wanted to give just one quick example of a paper that was published recently to give you a little bit of a peek into our thinking into why this particular paper made it into Science. So in this paper, which was just published a few weeks ago, the authors were studying the red knot, which is a migratory shorebird that breeds in the Arctic and winters in the tropics. And what they found is that birds born in the Arctic were growing to smaller size due to the warming that's going on in the Arctic. And when those birds became juveniles and flew to their wintering range, their smaller size and shorter bill did not allow them to reach their essential, most important food source. So they had decreased survival and decreased reproduction. And so it's the first time that climate change has been shown to have a negative impact on a bird, on anything, in a range that wasn't part of where the actual climate change was occurring. So it's showing complex effects of climate change on a species. So it's kind of a novel and striking finding. It's important for conservation. And then because it shows this rapid evolution, this rapid change of the bird's size and how that acts in the environment, it's a demonstration of a natural process, this rapid evolution. Okay, so getting back to sort of thinking about your own paper, there's a few things that I like to put out there for people to think about before they write the paper. So the first thing I like to tell people is to try not to be a slave to publication. So this environment is so competitive, and people are always feeling like they have to publish. But I think it's important to remember that we do the science because we like the science, and we write the paper because of the science. We don't do science because we need to write a paper. And I think that kind of thinking can really help people both kind of stay balanced within this crazy environment, as well as kind of have a full story when they're ready to submit. The other thing is to think about the question you're posing early on in your research process. So in some fields in particular, there's a lot of sort of exploration, which can be really good, but at some point you want to think about what question you're asking and why you're asking it. And then in order to do this, you really need to read widely in your fields. So one of the things that I feel sort of lucky in is that I read a lot. I read all the time. But when I was a researcher, I was lucky if I read one paper outside my field every 2 weeks. So I think it's really hard, and even within my field, I'd read a lot when I was writing a paper, but when I was analyzing data, maybe once a week at journal club or something. So it's a common thing we all have to deal with as researchers, but I think that if you can give yourself time to read, that really helps you figure out when your work is a conceptual advance. The other thing is to try to build on other people's knowledge instead of belittling other people's work. So I do see this quite often in papers where people will write, well, this was done before, but it wasn't any good because of this and this and this reason, and our paper is better because it does this. Well, that's fine, except then 2 years later, someone else is going to say, well, those people didn't do this and this and this. So the key is to just talk about what you've done and why it's important and what it adds, instead of trying to say it's better than this other person. The other thing, which may not be as important in your field, but perhaps I could imagine, is to think about your questions free of your research system. So what is an important question to ask generally in science? And then once and knowing where you're coming from, right? Knowing what in your field is being done, but then saying, okay, well, what if I just let go of my system that I work in? What could I think would be an important way to further this general field? And then once you've thought about that, then you kind of bring those thoughts back in and narrow them into the appropriate system. So you're thinking free of a system, but then you're asking questions appropriate to a system. Okay, so this is the recipe for writing a science paper. We've reached that point, so everybody can take their pictures and notes. So 2,500 words is the length of a science paper, which is quite short. But I think when papers are written in this way, they can be very good. So the key is, for the first only 1 to 3 paragraphs, you want to introduce your work by giving it context, sort of discussing why such a question needs to be addressed at this point, and then clearly stating what you're asking. The second one, and this may again apply less to your field, but provide some relevant background, whether it's on your system or on the question a little bit more, so that the reader can understand your perspective and what pertains directly to what you're looking at right now. And then you want to briefly highlight your methods, because the reader should not have to go to the supplement to understand what you did, and then clearly state your results. And then the last is you want to interpret your results and discuss their implications in just 1 to 2 paragraphs. So that's really how to fit a solid paper into 2,500 words. You get rid of a lot of the extraneous discussion that you might use in a longer form. And the other thing is to be concise in your sentences and to not use jargon. So be descriptive when you're describing things. Some really quick do's or don'ts. Do try writing before the study is done. It can help you be cohesive about what it is that you're producing here in this paper. Thoroughly review prior work. Be clear about your novelty and importance of this work. Don't oversell it, but also don't undersell it. Be clear about the results. What exactly did you find? Follow the scientific method. So have a question and a hypothesis that you're testing, at least in your mind or on paper, even if you're not stating the hypothesis in the paper. Be very specific in all cases. Do spend some time focusing on your figures. They really do help convey information. And this is really important. Have other people read your paper as many as you can with a very critical eye, because you want the potential errors or not best produced or constructed design to be caught before it goes to review at the journal and then has to be reviewed.
Excuse me?
Mm-hmm.
I find there are two things that would be very difficult for me to enforce. One is right before the study is done. I mean, somehow I need to have like the whole idea before.
So what I find, so a lot of people are like that, and that's why we put this there, because you do want, so here's the thing, a lot of us would get our data and then we kind of pull together our story in question. But you do want to know a little bit about what you're asking before you get the data, because that's where you figure out what your question is. That's where you should be figuring out what your question is before you collect the data and say, oh, that looks like this would answer that question. So when I say right before the study is done, what I'm talking about is formulating your question and why it's important in your field. And that you should be able to do without knowing what the data say. And so that's what I'm talking about. Yeah.
And the other one is follow the scientific method. I mean, often we are far from it. I mean, real research. So.
Yeah, so somebody else asked me about that today, and my own research was very much not of the kind of work where you could have a hypothesis and then conduct experiments. I did landscape and population genetics. So in that case, you can't do an experiment in the wild in population genetics. But what we can do is collect data, and then before you look at the data, think about, well, what am I mean, you have to think about the question before you collect the data, but you look at what you want to ask. So for example, I was interested in whether or not these big mountains were a barrier to dispersal for this species. So I can ask that question, and I can make a hypothesis. I can say, yes, I think these mountains are a barrier. And then I can collect the data, and I can test that hypothesis, even though I'm not building an experiment to test it. And so that's what I say when I say use the scientific method. What I mean is, make sure you're stating your question and you're having a hypothesis that you can falsify before you are looking at the data. Because what can happen is we can say, oh, this data kind of looks like this. Okay, the question I want to ask now that I've seen the data is this. And I think that's where you can run into trouble in terms of having, I mean, it's not a horrible way to do science. It's just that in terms of having a conceptual advance, you really want to think about what you're asking before, and what you want to test before you are collecting the data. Okay, quick don'ts. Don't rush to submit. So take the time to prepare the paper, and this including sending it to friendly reviewers. Piggyback, what that refers to is when you see a paper, let's say published in Science or Nature, and you say, oh, I kind of do that. I'm going to send mine in too, because those papers never make it in, those follow-up papers, so it's kind of a waste of your time. Don't slice too thin. That's what we talked about with this least publishable unit idea. Don't submit multiply. Most people know this. You can only send to one journal. Don't misrepresent prior work. That's a little bit what we talked about before with not belittling. This is another important one. Don't write chronologically. So many people still think of when they write, they'll think, okay, I tested this, and then we found this, and so that made us want to test this, and then we found this, so then we thought we better test this. And that's kind of how science works, but it's not how you should tell your story, especially in a short format. So all you want to say is what you asked, what you found, and why it's important. And then, again, don't use jargon, just get rid of it. Don't justify, just get rid of it. Okay, and then the last thing I want to discuss before we open for questions is the cover letter. So the cover letter is one of those things that people have really different ideas about. So some editors really do want to have a cover letter that kind of tells them what's in the paper, tells them why it's important, gives them a lot of information. I don't even look at the cover letter until after I've read the paper. So it really depends on the editor, and so I used to just say, oh, don't worry about the cover letter. But then I thought, well, that's not being fair, because some editors care. So now what I do is I just talk about the basics that should be included in a cover letter, but also keeping in mind that they should be brief. So the first thing is you want to state what you found, what your conclusions are, briefly. And you don't want to exaggerate, right? You just want to be clear. This is what we found. And then you want to state why you feel it's important and specifically why you feel it's a conceptual advance, because that's what we're looking for. And then the last one pertains to the fact that I have had many experiences where I've read a paper and I get to the end of the paper and I think, I have no idea why this person thinks this work is important. But then I go to the cover letter and I read this elegant discussion of why the paper is important, where it fits in the field, and I say, oh, well, that's why it's important. But I'm the only person who will ever read that. And the person who needs to read it is the reader. So what I tell people is, all that elegant thought process about why it's important, put that into your introduction, because that is where we need to know why it's important. And again, this process and this style may be very different from what you do for other journals, but this is kind of what works as a science paper. Okay, so overall, when you're writing for Science or Nature, what you want to focus on is the big picture. Where does your work fit in, and how does it advance your field? And then I hope I've opened the black box. I gave this talk earlier today, and somebody went, Pandora's box. So maybe I've opened Pandora's box. But I hope that it's been helpful, and I thank you, and I'll take any questions. Yeah.
So I don't know if this is a urban legend that when you submit and get rejected by Nature, then you send it to Science, but Science already knows about this, so it's not a good strategy, or vice versa. How much is it true or not? Or what is the communication between Nature and Science in this respect?
So there's zero communication between Nature and Science, except that I sometimes see my counterpart at meetings. So we do not communicate at all about papers, except for cases where a paper's been accepted and the author will say, there's another paper at Nature and we want them to come out at the same time. But in terms of communication prior to that, there's zero. But what does happen is people will say, okay, I tried Nature, now I'm going to try Science. That happens all the time, and vice versa. But the only way we know for sure that happened is if you leave Nature in the cover letter, or if you don't change the format. So there's some very small format differences. And a lot of people don't. So then we can say, well, it looks like it already went to Nature. So if you want to assure that we don't have any idea, then just make sure you're submitting in Science format and that you've made sure to go to the cover letter and taking out Nature. But yeah, well, there's no communication. In fact, I mean, there is kind of a friendly rivalry. So it wouldn't behoove us to try to work together in that way.
Incluso que any kind of science or scientific work needs to be published in Nature or Science, or if, for example, theoretical work is suited for...
Yeah, so theoretical work does get published in Science. I will say that it's at a lower rate, and I think part of the reason is that there needs to be, I mean, it gets back to this of a conceptual advance, and so there needs to be some way to demonstrate that this theory is really breaking through in a big way. And so I think when you have empirical data, it's sometimes easier to demonstrate that, because you can say, well, yes, I developed this theory, I tested it, and look, it really did move the field forward. Whereas theory, sometimes people can say, well, the theory is great, but does it apply? Now, again, this may be different in your field, because I know, like theoretical physics, a lot of it you can't test in that same way. But so we definitely do publish theoretical physics. In fact, we have a theoretical physicist who's an editor. So we do that. And certainly in my field, it's at a lower rate than empirical work, but it does happen. And it may be that in physics it's actually much higher than I know about. Yeah, no? Yeah.
In this respect, how true is it that you need to do a prediction that can be tested in the next few years when you publish a theoretical paper?
Again, kind of outside my purview, but I guess it would maybe depend on how easy it would be to test, right? So I could imagine that if you make a prediction that could be tested fairly easily, then the expectation might be, well, then let's test it. Whereas if you're making a prediction about something that we can not really test ever, then that's, obviously not a requirement, and there's probably, somewhere in between that those two fall.
Yeah. How was the front page selected?
You know, it used to be different. So from what I understand, it used to be that editors would sort of come together and say, okay, what papers do we want to be on the cover? Now the art department does it. The art department selects the cover.
Oh, I see.
Yeah,
It's
so,
not the importance of the paper.
well, they do always check with us and say, we'd like to use this paper on the cover. Do you feel that it's strong enough to do so? And so we have input in that way, and we can always suggest. We can say, hey, you know, I've got this really great paper that could be this really great cover, and put it forward, but they make the ultimate decision.
What about interdisciplinary science? I mean, there are a lot of work doing in, say, physics, for instance, network is a typical example. So there is a very important papers in science, starting from the very beginning of Laszlo Barabasi, famous paper in science, that already has about 30,000 citations. It was rejected originally in science. But then he fights. He told me that story.
Yeah.
And then it was a classic.
Yeah.
But there's still very few papers, say, in networks, very interdisciplinary, complex systems, this kind of thing. How do you deal with those papers?
Well, so we're very interested in interdisciplinary work, and I would say more and more work is interdisciplinary across fields. And so we certainly are interested, and we want it. It can be harder to review, because what I find, so the way you review it is you just make sure you have reviewers from all of the fields. So that part's not hard. But what I do find is sometimes, let's say you need a physicist and you need a biologist. Sometimes what I'll find is the physicist doesn't like the physics and the biologist doesn't like the biology, but the physicist loves the biology and the biologist loves the physics. And so you have those kind of issues where I think people within their own field can be a little bit harder on their part of an interdisciplinary paper, remembering that when papers are interdisciplinary, sometimes each component is not going to be like the most exciting part of physics per se or biology per se, but together they make an exciting move. So I think that that's the challenge, is getting reviewers to understand that, well, we're not asking you to just review the physics part as if it were alone. We're asking you to review the physics part as if it, you know, as it plays into this larger thing. And so I think reviewers are getting better at it. And we actually publish a fair amount of it across fields. So like in my field, biomechanics, we often publish collaboration between physicists and biologists about, you know, whether it's bio-inspired materials or movement based on animal movement. And certainly in other fields it's happening too. So I think it's growing, and we're interested, and we recognize the pitfalls.
Okay. So, according to what you have said, that it has to follow the scientific method, it would be more acceptable to write papers based on experimental data?
No, yeah, I don't mean to say that. I don't mean to say that. And again, keep in mind that I usually give this talk to biologists, and my physicist colleagues might say slightly different things. But what I mean to say in that sense is just make sure that you, and again, with theory, it's not quite the same. I mean, although with theory, I guess you have to come up with some theory and then test it, right? So the idea, and test it within the theory, right? So the idea is to, when I say use the scientific method, is to just make sure that you're testing your hypotheses in some way. It doesn't have to be experimental, and when it's theory-based, you have your own ways of figuring out whether your theory is correct, right? And that's what I'm talking about. Yeah.
Thanks.
Maybe another one
Yeah.
for the future. Nature recently, well, not that recently, but a few years ago, besides the other journals in the Nature family, he introduces scientific reports, which is the open access version, which has been kind of successful among many other journals that have this tendency to open journals. Now, very recently, as you said, science do the same with Science Advances. And the question is, what is the success so far of Science Advances, which is just a few months or maybe
Yes,
least
about a year. Yeah.
about a year?
Mhm.
And what happened in that year? How do you see it from inside?
Mhm.
And what is your perspective on this open access tendency,
Mhm.
especially with this announcement of the European Union that you mentioned?
Mhm. Okay, so Science Advances doesn't yet have an impact factor, so it's hard to say where it falls out in that way. But what I have observed is it seems to be doing quite well. It's getting a lot of submissions. The papers that are published seem to be getting attention, and they seem to be getting cited. So it seems to be doing well. I think there is a need for things like Science Advances, Nature Communications, scientific reports, for places where research can be disseminated rapidly and just more of it, because there is so much out there. So so far, so Science Advances is separate from science in terms of operations, and I don't know how much analysis they've been doing of their own performance, but from the outside, what I believe is that it seems to be doing quite well. And then in terms of open access, it's a really complex issue, and I think there's been a real bandwagon for getting on to open access for good reasons. I mean, it does make sense that all papers are available freely, especially when people are paying, taxes are paying. However, you have to pay to publish your work. And even though in some places, particularly places where the push for open access has been the strongest, the US and the UK, funding agencies are putting in allotments to publish in open access. But that's not the case everywhere. So there are a lot of, I even know people in the US who say, I can't publish this paper because I don't have funds to do it. And definitely it's happening outside of the US even more. So that's a problem that I think is going to have to be dealt with if open access really does become the way that all things are published. The other thing I have a little bit of a struggle with is the fact that there's a little bit of a conflict of interest because the author is paying to publish their work, which ultimately can be taken for granted by predatory journals, which is happening. So lots of authors are getting, requests from journals wherever they are. Well, you pay me $10,000 and your paper will get published. And it's hard for authors to tell the difference between a real one, because the regular open access journals do the same thing, and a false journal. So I don't think it's the silver bullet that its advocates want to really say. I think there's a lot of problems that have to be dealt with. I would love to see some brainstorming about paying. So I would love to see something put forward that's not just reader pay or author pay. I don't know, ads? Nobody wants to see an ad on a PDF, but wouldn't it be nice not to have either person have to pay? So we'll see. But I think regardless of all these problems, it's coming. That's the wave of the future.
What about retraction? What is the process inside science to decide to retract a paper?
Okay, so there's two processes. So the first is kind of author-based retraction. So that happens when one author or all of the authors realize this is wrong. Something is wrong in this paper, and you hope that all of the authors on the paper agree with that. Often that's not the case. So if all of the authors agree, and then they write and they say, we need to retract this paper. That's simple. It's retracted if they feel that they're wrong. The other thing that can happen is kind of partway. So some authors feel that it's wrong, and other authors feel it's right. Then you have to have some kind of investigation to determine who's right and who's wrong. And those can go on for a very long time. And eventually, sometimes the editor-in-chief has to make the call. And if there's been enough doubt cast, they will often retract the paper even without the support of all the authors. And they'll say, this and this and this and this authors support retraction, these do not. The third way is that the editor-in-chief will sometimes decide based on evidence that's being brought forward that a paper is wrong, and then they will retract the paper even without the consent of the authors. So those are the three ways that it can work.
As an author, sometimes when one submits and then receives back the reports, it might happen that one feels that the referee didn't understand the paper. So one has two options. Either attack the referee or be kind with the referee? And so, as an editor, what would be your suggestion to them?
It's never good to attack referees. Just because attack is it's not a good way, I believe, to do anything. It's very, it's caustic, and that can cause problems. And certainly, it kind of depends on where you are in the process, right? So if your paper has been sent to revision, or, if it's come back, we sent it to revision, and you're revising it, that means we've looked at that review, and we still believe we're interested. And therefore, it really behooves you to be kind, to address all of the concerns as much as you can, or to refute them in a kind way. Instead of attack, this referee's an idiot, they don't know what they're talking about. Instead you say, so this particular component that referee number 2 brought up, we believe is in error because of X. So that's the way you do it when it's in revision, because we've obviously given you the benefit of the doubt. We're saying, look, we believe this, we still believe in this paper. You do need to address this reviewer, but clearly we're giving you the chance. The second case is when it's been rejected. So in that case, you do have the option to appeal. But science policy is very strict about appeals. We can only permit an appeal if you can demonstrate technical error or bias in the reviews, and that was the driver of our decision. So, if you feel that a reviewer really has not understood at all, then what you do is you appeal, and you very calmly and without attacking them demonstrate why you believe they were technically in error or in technical error. And that's the way to do it, because the thing is, I tell all authors, always sleep on a rejection, always give yourself time to calm down, because these kinds of things can always be resolved better when you're not angry and attacking, because then people are like, whoa, I don't know, this guy, he's loose cannon. So you want to be careful about that. Jim, then you.
I just saw statistics that 99% of reviewers for the physical review come from Europe or from the United States. What is the number for science?
It's definitely not that high. So we are supposed to be getting, right now, at least 25%, but some of us try for higher. So, it can be hard in some fields to find people, if you're excluding US, UK, and Europe, depending on the field. But we definitely always are trying to get people internationally. So again, it's one of those things where we are aware of the problem and are trying to fix it. And it takes a little while, but it is in our guidelines as editors to try to ensure that you are getting at least 25% international reviewers, not UK. And so that's what we're trying to do. Yeah.
What about media? Science pays a lot of, media pays a lot of attention what gets published in Science. What is the relation between the journal and media in general?
Yeah, so we have that news section in Science itself, but that is it's a different silo than editorial. So they do whatever they want. Sometimes they cover our papers and sometimes they don't. Aside from that, we have a press department, just like universities do, where we put out press releases. And that's about it. So we want to put our papers out there, and it's up to them to decide whether they want to take them. And so I think the key is that journalists for a long time have followed Science and Nature, and so they show up and they follow, and so a lot more coverage comes from Science and Nature. However, increasingly I see a lot of coverage of other journals. I hear it on the radio, I read it in New York Times. So I think with the internet, journalists are having a much easier time finding good science from outside of Science and Nature. So I think that's improving.
Bueno, pues nos tenemos que ir porque tenemos otra reunión, pero les agradecemos mucho su hospitalidad y que nos hayan invitado a compartir con ustedes esta experiencia. Muchísimas gracias.